Alrighty, in today's lesson, we'll be looking at 7.4, which is graphs of sines and cosines. Now, if you look in your book, they go through the coordinates of sines and cosines, and they give you about 10 of them, I believe. There you go. Actually, about 16 points within one period. And we'll talk about what period means. But just so you know, sines and cosines are oscillating functions, so they just keep repeating themselves over and over again. So a period is basically all the points in which hasn't started repeating itself, and there's about 16 points that you can actually plot to get a very good graph. I don't know how much in detail in the homework because that you have to do because on the homework what I saw was you were just picking the correct graph. So what I'm going to do with that information is I'm going to give you what I like to call the five main points. With the five main points, you can figure out exactly where which graph is the correct answer by just looking at where it crosses the x-axis and its maximum and minimum values. And at what time does it hit that, or at what period it hits that? So that's what I'm going to focus on. So with that said, let's start with just our sine function. So sine of x has five main points. So the five key points. Now, again, the book gives you 16, but these are the main ones. So you have 0, zeros where the graph starts, pi halves, comma, 1, that is the max of the graph. Then you have pi, comma, 0, that is where it crosses the x-axis. Then you have 3 pi over 2, comma, negative 1, that would be the minimum. And then you have 2 pi, comma, 0. So when I'm looking at this, oh, man, it's hard to draw a straight line. Let's try this again. And that's the best we're going to get. So if we have a graph right here, this would be 0. And then this right here would be pi halves. This right here would be pi. This right here would be 3 pi halves. This right here would be 2 pi. And then if I wanted to keep going, this right here would be 5 pi halves. And so on and so on. Going up by halves. You could see some that are going up by quarters, so they could have more markers here, but this is the main gist. So when I say the five main points, a sine function will start at the origin, and at pi halves 1, it'll hit a max. At pi comma 0, it will go back to the through the x-axis. At 3 pi halves negative 1, it'll hit its min. At 2 pi, it will go back through. Right? So then if you graph the other 13 points it gives you there, you could plot all these different points all right here to get a consistency. But in general, if you're a really good drawer, this is what your a one period sine function would look like. If you wanted to keep on going, this point right here would start repeating. So you would have one here, and then I could go technically at negative pi halves, and I would have one here. And then it would just keep on going and going and going, just keeps repeating. So we call this spot right here to this spot right here one period because it doesn't repeat any of those points. And then after that point, it does. So we'll talk about like how to find the period and kind of what to go from there. But that is your five key points for sine. The next thing we're going to look at today is your five key points for cosine of x. All right, and they are 0, comma 1. So it starts at the max. Pi halves, comma 0, then goes to the x-axis. Pi, comma negative 1, it then goes to the min. 3 pi halves, comma 0, then goes back through the x-axis. And then 2 pi 1. And then we'll finish back at the max. Here we go. So again, we'll start at 1 here. This will be pi halves. This will be pi. 3 pi halves. 2 pi. And of course, this will be 5 pi halves. Over here, this will be negative pi halves. All right, so then at pi halves, it would go through the x-axis. At pi, it would hit its minimum. 3 pi halves back to the x-axis, 2 pi back to the max. So then we have a graph that looks like this. Again, those other points kind of help you with that curve. But again, what I saw on the homework is that you were just picking the correct graph. And so then here, again, I would cross at that point at 5 pi halves and then keep repeating. At negative pi halves, I would cross at that point at the x-axis and keep repeating, right? But in general, this would be 1 period. Right? From that, we then have our transformations from those 5 points. And these are what the two functions would look like. You have f of x equals a times sine of bx minus c. And then you have f of x equals a times cosine of bx minus c. All right, so they both look generally the same with the a, b, and c, and they all do different things. So for starters, when we're given this, we have what we call the amplitude, which just tells us how high it rises and how high it goes down, but it'll be equal to the absolute value of a. So whatever the a is will tell us what the amplitude is. We can also calculate our period. We saw naturally our period is just 2 pi, but if there's a b in there, then we'd have to take the 2 pi and divide it by the b. So it could decrease or increase the period. We then also have what we call a phase shift, which it will just take these oscillating functions and move them left or right. So it gives it a new starting value. So maybe we don't start at x equals 0. Maybe now we start at x equals pi halves or whatever the concept is. But that will just be equal to c divided by b, and that will tell you what you're adding or subtracting to all your 5 main points. Then you have frequency, which will be b divided by 2 pi. Just tells you basically how many shifts or how many phases or periods are within that frequency. All right, so a couple of things to also note here when writing these out for your 5 main points. Whatever the amplitude is, that's going to affect your y. So you want to multiply your y value of your 5 main points. Your period, you don't have to do anything with it. That is telling you what's it doing. Your phase shift, that's moving your x value left or right. So you want to add your x value to this. And again, frequency, not such a big deal as well. So those are the 2 main things that's going to affect your points. But let's look at some problems to put this into practice and make this make more sense for you. All right, so let's look at number 7. It says f of x equals 5 plus 4 cosine of x. All right, and it asks us to determine the amplitude, the period, and phase shift of each of the following functions. So in your homework, you're not going to be graphing all the time, but you're going to use these values to figure these all out. All right, so for starters, it says amplitude, which is equal to the absolute value of a. What you have to determine is what is the a? The a is going to be the number next to, or that's being multiplied to the trig function. So in this case is the absolute value of 4. So my amplitude is 4. Right? Straight up like that. The next thing you want to do is figure out your period. And your period is 2 pi divided by b. Well, your b would be the number that's being multiplied to the x. But obviously, we don't see a number. So this becomes 2 pi divided by 1, which will remain 2 pi, meaning nothing compressed it, or stretched it out horizontally. So therefore, we stick at just 2 pi. The next thing I want you to know or find is the phase shift. So the phase shift is equal to C divided by B. All right, so the C is usually what's being added inside. So like if I had a plus a C here, but I don't. The C here is 0. So that would be 0 divided by 1, which would be 0. So that means that there is no phase shift. And then I think that's it, right? Okay, so but one thing to note here that we didn't see, this value right here would shift when we talk about graphs up and down. So what we would do with this value is we would add it to the y value. All right. Here we go. That's it on those. So let's do quite a bit of those, because there's quite a bit of those on the on your homework. Let's make sure we can discover all of them. So let's look at number 11. This one is g of x equals -3 cosine of x plus 7. Again, let's label everything. This right here would be my A. My B is located here, and my C is here. For I guess sake of argument, we'll just call this guy like plus K, but we don't need it right now. We'll need it for graphing purposes, but for now, that's all we need are A, B, and C. So again, amplitude, I'm just going to call it amp now. It's going to be the absolute value of -3, which gives me 3. All right, and then we go and we look for period, which again is 2 pi divided by b, which again is just 2 pi divided by 1, which gives me 2 pi. And then if we look at our phase shift, it would be, c divided by b, which in this case is 7 divided by 1, which is just 7. But that's the part. So it shifts 7, but if you remember, let's go back over here. The function is a minus. So every time that's inside parentheses, we always got to think the opposite of what it does. So even though we get a positive 7, this would mean that it shifts left 7 units. So if you end up with a positive, you're shifting left. And then if you're ending up with a negative, you would shift right. Right. So that's that part here that I forgot to highlight when it was because it was a minus. All right, let's look at number 12. This one is f of x equals 2/3 sine x. So this is my A, my B, and then I don't currently have a C. So that means that my amplitude, I'm not going to label A. I'm just getting shorter and shorter here. So that's the absolute value of 2/3, which is going to be 2/3. My period, I'll label as just P, would be 2 pi divided by E, which is 1. So that's just 2 pi. And then my phase shift, I'm just going to write it as PS. Or phase shift is my 0 divided by 1, because there's no C. So that's 0. And so there's no phase shift. All right. Too easy, I hope. Let's look at another one. Let's look at number 13. All right, number 13 says f of x equals 2 sine of 2x. So here's my A, my B, and then I don't have a C. So that just means that my amplitude is the absolute value of 2, which is equal to 2. My period is 2 pi divided by 2. So now my period is pi. So notice when b is greater than 1, my period shrinks. So I'm compressing my sinal waves to be more narrower. And then my phase shift would just be 0 divided by 2. So even though my B is 2, it's not going to matter because there's no shifting. So no shift. All right, let's look at another one. Let's look at number 15. Number 15 says g of x equals 3 sine of pi theta over 2. Now, you can rewrite this as 3 over 2 sine of pi theta. So when we're labeling our stuff, this becomes my A, this becomes my B, and then I have no C. So my period, is that the first one we're looking for? Nope, amplitude is the first one. Okay, try that again. My amplitude will be the absolute value of 3/2. So that's 3/2. My period would be 2 pi divided by pi, which in this case is 2. So you can have a period that no longer has numbers, or sorry, no longer has pi in it. And then my phase shift will just be 0 divided by pi, which will still be 0, so no shift. All right. So then we'll look at number 16. So number 16 says g of x equals cosine of 3 pi theta minus 2. So in this case, again, label your stuff. Here's my A, my B, and my C. So my amplitude in this case is the absolute value of 1, which is 1. So if there's no number there, like you have the amplitude, period would be 2 pi divided by 3 pi, which in this case is just 2/3. And then my phase shift would be 2 divided by 3 pi. And then you can't reduce that. So we leave it that. But technically, this is a -2. So therefore, that means this shifts right 2/3 pi. Or 2 over 3 pi. All right, let's look at a different one. Let's look at number 17. This one says f of x equals 0.5 sine of 8x plus 1. So again, this would be my A, this would be my B, this would be my C. So my amplitude would be the absolute value of 0.5, which is just 0.5. My period would be 2 pi divided by 8, which in this case becomes pi fourths. And then my phase shift will become 1 divided by 8. And because it's positive, it would shift left. All right. All right, let's look at number 19. Number 19 says g of x equals 8 cosine of 2 pi x plus 4, all divided by 5. Remember, we can rewrite that as 8/5 cosine 2 pi x plus 4. Let's label our information. So this is my A, this is my B, this is my C. So my amplitude here would be the absolute value of 8/5, which gives me 8/5. My periods would be 2 pi divided by 2 pi, which in this case is 1. My phase shift would be 4 divided by 2 pi, which we can simplify to 2 over pi. And again, because it's positive, it will shift left. All right, so I got one more, and I think I've given you all the examples that you could possibly see on your homework. So let's look at number 20. G of x equals 2 minus 3/4 sine of -3 plus x. So my amplitude Oh, let's label first. This is my A. This is my B. Oh, I lied. This is my B. This would be your C. So you can rewrite it if you would like, but just know that the B is what's being multiplied to X and the C is what's either being added or subtracted to the X. And then, of course, this is our K, but it's not part of finding any of our information. So this is the absolute value of -3/4, which would just be +3/4. Our period here would be 2 pi divided by 1, which remains 2 pi. And then our phase shift um, would be -3 divided by 1, which in this case is -3. So that just means it shifts right. Right. And there you go. So that's how you find amplitude, period, and phase shift. That's plenty of examples for you to see. Let's get into graphing. So you can see what you have to do on the graphing. Again, on your homework, what I saw is that y'all just have to find or match. It's like a multiple choice where you have to match it to the correct graph. So you don't have to like go find points and stuff like that. All right, so let's look at number 23. This one says g of x equals 3 sine of x minus 2 pi. All right, when dealing with graphing, you want to know what all these numbers do. All right, this is my A, this is my B, this is my C, and then I don't have a K. So here is my 5 main points for sine. We have 0, 0. We'll call them old points. And then we have pi halves, comma 1. Then we have pi, comma 0. Then we have 3 pi halves, comma -1. And then we have 2 pi, comma 0. So now we want new points or sine. Now for this, the A we know will multiply the Y. We know our phase shift, which again is C divided by B, will add to our X. And then we know our K value will add to, well, I'll just write it right here. This will add to the X. And then your B here, I'm pretty positive, but we'll definitely do an example on the next one. This multiplies to your X. So what we can do is we can multiply first and then apply any adding after that. So I'll deal with we can do X then Y, doesn't matter. So if I'm multiplying by my B, which is 1 in this case, that'd be 0 times 1, which will remain 0. And then I would add my K, which will be 0. So the X value, by just doing this work alone, will not change my answers. The B is 1, the K is 0. So X will not change, only my Y will. So I'm going to multiply my A or my Y and then add my phase shift. So let me go ahead and calculate the phase shift here. That'd be -2 pi divided by 1, which is -2 pi. All right, so what that means is I'm going to do 3 times 0, which gives me 0. And then I'm going to add -2 pi, but we have to do the opposite because remember, this is going to go to the right. So we multiply A by 3. Okay, yeah. So let's make sure we do this right. So because I'm going negative 2 pi, I have to actually add it. So this would be 2 pi. And then this right here, okay, we know the x would remain the same. 3 times 1 is 3. Oh, man, I got that. Okay, hold on. So this k is actually adding to the y, not the x. And I wrote it x here and I added it to the y. All right, hold on. Getting all sorts of confused. I was gonna say this math's about to be difficult. All right, anyways, okay, so let's do this one more time from the top. So x value, 1 times 0 is 0, and then I'm going to add it to the phase shift. So then that, and again, I go to the right. So that's going to be 2 pi, comma, this time I'm going to take my y value, 3 times 0, and then there's no k. So my new point should be 2 pi, comma, 0. And then I come over here and I do the same concept. And I actually think, and that's what I was looking at, is you can actually subtract the 2 pi, and I believe you would still get, like if you wrote negative 2 pi here and you subtract it, you would still get the same part of the graph. So I don't think that part actually matters when finding new points. It does matter with your phase shift, the correct notation for it. But when doing the math, I think you would still find the same points within that same graph. All right, so here we go. Pi halves. All I got to do is just add negative pi, or I'm going to add 2 pi to that. So pi halves plus 2 pi would be 5 pi halves. And then 1 times 3 will give me 3. And then I got pi plus 2. That would give me 3 pi. And then 0. And then this would be 7 pi halves, comma 2, or comma negative 3, because that would be what 3 times negative 1 is. And then this would be 4 pi, comma 0. So when you're picking your graph, you would want, again, if we're still going by pi halves here, and I just want to show you what will happen too if you went the other direction. So pi, 2 pi, 0, 5 pi, 3, 1, 2, 3, 1, 2, 3. There you go there. 3 pi would be 0, 7 pi would be negative 3. So this would be your new graph, and you would be looking for this graph as your answer choice. So basically, if this whole graph was, right here, and then it got stretched vertically and then shifted. But if I was to subtract this, then technically this would be negative 2 pi. So we'll just do markers here. So we'll do 1, 2, 3, 4. This would be negative 2 pi, give or take. This would then be 0. And then this right here would be at 3. And then this would be at 0. So that would be if you were to subtract it 2 pi. But if I kept this pattern going, notice I get right back here as well. So even if I would have subtracted 2 pi, I would have gotten a correct portion of the graph. But what's reality happening is this original graph here has now become moved over. But if you moved it to the left, you would still actually get a correct one. But for sake of the phase shift and what it's actually doing, that's what you need to do. And it doesn't say how many. A lot of times it will say you have to do 2 periods. So you just repeat the pattern twice. But with those 5 key points, it's so much easier to specifically find which graph is yours rather than going specifically into detail. All right, let's do one more of those. Let's look at a cosine one. So we'll look at number 25. This says f of x equals 4 cosine of 3x over 2 plus pi halves. So again, this is my a, which will be multiplied to my y. This is my b, which will be multiplied to my x. This is part of my phase shift. So my phase shift would be c divided by b, which in this case is pi halves, divided by 3 halves. If you keep change, flip that, that is pi thirds. So the 2's will cancel. And so this is what I'll add to my x. And then I don't have a k. And again, that would be added to the y. All right, so for cosine, the original points are 0, 1, pi halves, 0, pi, -1, 3 pi halves, 0, and then 2 pi, 1. Our new points for cosine. So here we go. I'm going to do my x's first. Ooh. All right, so cosine, I multiply by 3 halves to 0, doesn't do anything, but then I need to actually go left. So I'm going to subtract pi thirds, so I get negative pi thirds as my first point. Yep. We'll check that here in a second. Oh, and then my y would be 1 times 4, and then I'm not adding it, so it'll just be 4. And then this one here, this would be pi halves. So that times 3 halves would be, was that 3 pi fourths? And then I'm going to subtract 3 pi fourths. So here's some side work. So 3 pi fourths minus pi thirds. That would be 12. So let's see, that's going to be 9 twelfths minus 4 twelfths. That's 5 pi twelfths. All right, so that's 5 pi twelfths, comma, and that just remains 0. Which is again pi thirds, 3 pi fourths. So that would be, hold on, doing some math in my head. 2 pi 6, that'd be pi thirds. That's it. Okay. So, because then, yeah, that'd be 2. So like pi halves times 2 thirds would give you pi thirds minus pi thirds, because this is pi thirds. You would get 0. Yeah. Okay. So, okay, hold on. I forget that part all the time. So when we multiply, we're technically multiplying by the reciprocal of b. So I have to actually multiply by 2 thirds to my pi halves. And if I multiply pi halves times 2 thirds, I end up getting pi thirds. And then I subtract my pi thirds because I'm going left, and then I would get 0. So this is a 0, 0. I was wondering why I wasn't matching. All right, so that's what you do there. So let's do another one there. So that would be pi times 2/3, so that'd be 2 pi thirds. And then you would subtract pi thirds from that, and you would get pi thirds. So this is now pi thirds, comma, -4. And then take your 3 pi halves times 2/3. So let's do that work. So 3 pi halves times 2/3. I see my 2's and 3's would cancel. And I'm left with just pi. Now I can subtract pi thirds from that, and I'm left with 2 pi thirds, comma, 0. And then I'll take 2 pi times 2/3, and this will give me 4 pi thirds minus pi thirds, which is 3 pi thirds, which is just pi. So then I get pi, comma, 4. Yep. And so when we do this work here, when you graph it, you'll be looking for these points now. And these are going by thirds, so I'm going to adjust it. So this will be negative pi thirds. This will be pi thirds. This would be 2 pi thirds. And then this would be pi. So I then go 1, 2, 3, 4, 1, 2, 3, 4. So I'm looking for something that looks like this. So what we can see is that this guy shrunk horizontally, like it compressed horizontally, it stretched vertically, and then also shifted a little to the left, because originally this point was supposed to be right here, but this shifted left pi thirds. So this would be the point you're looking for. But it's a lot easier to do all these adjustments with these 5 points than with the original 16 points. All right, so hopefully that works out. Just don't forget this little part here, that when you multiply, you want to multiply by the reciprocal of b to your x. All right, and then of course, this has some application. So let's look at that. So let's look at number 47. It says a baby is playing with a toy. See, it says use the relationship between frequency and period to answer the questions. All right. 47 says a baby is playing with a toy attached above his head on a cold spring. The baby pulls the toy down a distance of 3 inches. So here's a cool. Do my best there. And we'll say that's 3 inches from its equilibrium position, and then releases it. The time for one oscillation is 2 seconds. Find the amplitude and the period per period, then give the function for its displacement. So then we got to come up with its function. All right. So amplitude is pretty easy. This is the amplitude, how far it is stretched. So there's your 3, which represents the A value. All right. And then our period, this is our period. It takes 2 seconds to do that. So 2 seconds is your period. And so to write out this equation, I don't know where the D came from. 2 seconds. So to write our equation, remember our equation's like f of x equals a trig function. And I think I'm going to go with cosine, but it doesn't really matter, I don't think. And then bx plus c. All right, so I don't have a phase shift going on. So I can go ahead and I know I'm not going to have a c. My b, so I know this is a, my b found by period. So period is 2 pi divided by b, and I know it's equal to 2. So to solve this, it becomes 2 pi equals 2b, then divide by 2, so b would equal pi. So there we go. So that becomes f of x equals 3 times cosine of pi x. All right, so using the information we got. So this is my amplitude, this is my period, And then using the period, I use my period formula, I can figure out my B and plug it in. If I had a phase shift, then of course I could use that equation as well. Right? And that's it. So it can be challenging looking, but it's not too bad. Let's do one more, and then I think I've done everything that you will see on your homework. So number 50 says a leaf floating on the water of a perfectly calm pond is suddenly disturbed by a, oh, never mind. Let me go back here real quick. You do want to use cosine since the starting value is at 0. So it's at its equilibrium. So that means 0 or the max, not the max, sorry, not the when doing these springs, you want to use cosine because when it's stretched to its max, that's where the cosine starts. So if we would have started with our equilibrium, then we would use sine. But since we're starting from where it's stretched out as its max, that would be its cosine. So if I would have started at a spring here, like at its equilibrium, and then it wanted me to then stretch it and find its equation that way. Now it's a sine. But since it was already stretched and then let go, and I'm looking for that oscillation, that's why it's a cosine. So I want to throw that in there. All right, number 50, sorry. It says a leaf floating on the water of a perfectly calm pond is suddenly disturbed by a series of waves caused by a landing duck. At time t equals 0 seconds, the leaf initially bobs upwards 5 centimeters and then continues to oscillate up and down with a period of 2 seconds. All right, so at time t equals 0, the leaf initially bobs upwards. So this will be a cosine. We're starting with the max or the min. So this will be an amplitude of 5 centimeters and then oscillate ups and down for a period of 2 seconds. So our period is 2 seconds. Okay. Part A says find a function that models this simple harmonic motion described. So again, that would be f of x equals so that'd be f of x equals a cosine of our bx plus c. And again, we don't have a phase shift, so you wouldn't have a c. So this will then have your amplitude of 5 cosine to calculate the b. We know the period is equal to 2 pi over b. We know it's equal to 2. We did this math a while ago, but we'll do it again. So b times 2 is 2b divided by 2, and we get pi is equal to b. So then we can plug that in, and now we get pi x, and make that or f of x or however you want to write it. All right, so from that point, it then says, assuming the amplitude of the wave diminishes over time by a factor of e to the negative t-fifths, modify your simple harmonic motion model accordingly, and then graph the results. All right, so since we now have an adjustment period, all you have to do is you're going to replace the amplitude, so this is part B, with what the phase is changing, which I believe was e to the negative t fifths, and then everything else will remain the same. And then after that, that's pretty much it. Graphing wise, I don't think it had you actually graph it, but just so you have a graph for it, it said it started at 5, so we're right here. And so therefore it goes like this, and then it'll come up, and then it doesn't go up as high. So then it kind of, the leaf doesn't bob as much. So then it kind of does this. So that's what a harmonic one is. Had it started t equals 0 and it said here, and then you moved it, then I'd be here, and then now I have a sine function. But because it says it started at 5 centimeters, I would then go like this. But I think on your homework, it might say that it started here, and then it was moved up 5 centimeters to start bobbing. So then it was here, and then drastically go like that. All right, other than that, that is all that I got. So if there's anything else I can help you with, just reach out. See you in the next video. Bye.